mega webinar series, we are so fortunate to have the different, the speakers from the different parts of the globe. They are all eminent researchers, academicians, industrialists. So they have come forward, happily agreed our invitation and sharing their thoughts. So the students, faculty members, researchers, industry professionals, whoever are attending this, the webinar series, they are getting their knowledge enriched a lot. This much I can, openly tell you, because I've interacted with so many students about their feelings about the center of Saturday manufacturing talk. Everybody is enjoying. And today we are very fortunate to have the Professor Sujit Banerji. Professor Sujit Banerji is the Emeritus Professor of Operations Management, Warwick Manufacturing Group, which is in University of Warwick in the UK. Globalizations, outsourcing, offshoring, supply chain, IT infrastructure, operations management, including services management, are the academic specialties of Professor Banerji, while executive and programming management are his professional skills. He was appointed to his present positions in 2007. His initial focus was on utilizing his industrial and academic experience to benefit WMG's successful master's program both in UK and overseas. We all know the WMG is very much famous for industry, academia, academic research, and also their courses. Prior to coming to the University of Warwick, Professor Banerji spent more than 30 years with IBM, almost all of it in the USA. With IBM, along with publishing 80 major international papers, he won numerous awards for his work. He switched to full-time academia in late 2004 when he retired from IBM. At IBM, he held a number of executive positions in systems engineering, marketing, business development, product management, and information technology as the company made transition from manufacturing into services. Professor Banerji studied at IIT Kharagpur, distinguished alumnus, BTech degree in mechanical engineering and MTech in industrial engineering. He then did his PhD in operation research on ICI Commonwealth scholarships at the University of Manchester and Cambridge University, as his thesis professor moved back and forth between these universities. With this, the small, very brief information about Professor Sujit Banerji, I request him to deliver his talk. Professor Banerji would be talking about the cloud computing.
Thank you, Professor Paul, for that very nice introduction. I didn't know who you were talking about. Seemed too good to be true. That was me. Yeah. But anyway, thank you very, very much. And to the attendees, I think this presentation probably will be a little different to the typical Saturday manufacturing talks you've been having. But I hope it'll be of interest for you, and I hope it'll be of some use for you. See, because this is not a topic which is core mechanical engineering. It's a topic that, of course, is now absolutely unavoidable in engineering, like in all other fields. But IT is something that's ubiquitous. It just pervades everything. You cannot do anything these days without IT. So I thought it might be of interest for you to learn a little bit about the history of IT and where we have come from and where we are now. When I was a student at IIT Kharagpur, of course, there was no computer center. There were no computers. We didn't have any computers. We didn't use any computers. We didn't even know about them. Today, of course, it is unavoidable. I think every student has one or more computers. Almost everything you all do is on computers. And so therefore, it's not core engineering, but it's, of course, something that is very, very useful in engineering. These days, nothing is done in engineering without using computers. I could have talked of one or two specific applications like Industry 4.0 or whatever. I know you're doing that in a big way, etc. But I thought it would be more useful to give you a history of computing and where things have come from. You know, these days, everybody talks of cloud computing. Everybody talks of, cloud computing is everything. And so I thought I should explain a little bit about cloud computing and where it has come from and how it has come there. Whether I'm going to put my charts on now. To put my charts,
So
Amrita?
yeah, you need to click the share button.
Share button down below, huh?
Yeah, and then you'll see the screen.
Yeah, share button. I've clicked on screen.
Yeah, then share.
And then clicked on
this
yeah. Share
the screen. Yeah.
Yes.
Now you open your PPT.
Open my PPT.
Yeah. And
I open my PPT here.
You can see your PPT. You can please go to the slide, the slideshow mode at the bottom, just beside the Zoom button and all.
Yes. Go to the slideshow. I have a problem.
Yeah, you can remove those ads and all these things. Yeah.
Yes, I have a problem with my system with these ads coming in.
Yeah. Now we can.
I'll get. Yeah.
Again, open your this PPT.
Yeah. Open.
Just you have already shared the screen.
Yes, I've opened the PPT.
Yeah, PPT has come. So just go to the slide show mode.
Yeah. Something is covering that, so that's why I'm having difficulty.
Yeah. Now. Yeah. Click that one. Yeah. Just do that.
Something is covering it. That's why I'm having difficulty.
Click.
Okay.
Click.
Okay. I think we're done. Okay.
Yeah. Excellent. So please
right. Can you all see my chart?
Yes.
It says you can title chart. Okay. Yeah. All right. So, as I was explaining, that cloud computing is all pervasive now, and the question becomes to many people, it's a revolution. Something incredible has happened, and now we have cloud computing, or is it more an evolution, that a gradual change from things that have been in the works for the last 50 years? So I'll take you back, starting 50 years ago. That shows how old I am. I was a student more than 50 years ago, so I'll start back at that time. When I was a student, at that time, computing was could have been shown in this chart. My next chart. It shows computing yesterday, 1965. Are you on that chart? In the middle, it says computer center. Are you on that chart? Shujo, are you seeing that chart?
Yes, we can see that one.
All right. And in my time, we used to walk to the computer center. So I understand in IIT Kharagpur, you have a computer center now. So imagine you had to walk from your hostel to the computer center every time you want to do something. We'd go one day, we'd put in our job one day, and we'd have to come back the next day and get the printout of the results. And the job we'd take would be in punch cards. You probably heard of punch cards. If you open that door into the computer center, next slide, I'm on the next slide now, which shows computing yesterday, 1970. If you open the door, when inside the room, that's what you'd find. The main rectangular box there is the actual computer. In those days, they used to be called mainframes. Mainframe would have a number of channels to which there were some storage devices attached. Those are on the left-hand side of the picture. Drums, discs, tape. Drum is now obsolete. You don't find drums anymore, but disc and tape is still around. And then you'd have a console. That was the driving place where the computer was driven from. You'd have a printer where you'd get the output, and you'd have a punch card reader, which was the input. What is your input now? What's your input device now? Anybody in the audience? Input device now. What do you use as your input device now? The input device today is the keyboard. And what's your output device? Output device is the screen. So you can see how these have changed incredibly. So that was computing in the 1970s. It required a whole room. Then you went on a few years later, in 1980, you can see all the things are still the same. They were all took one whole room. But the new thing is that the teleprocessing got added in. So you'd have a teleprocessing controller, and you'd have terminals. The terminals could be 1 to 5 miles away. They're all wire connected, actual physical wire connected. So you could see how limited they were in terms of how far they could be and how many you could have. On the chart, I've written dumb terminals, terminals dumb at users' desks. They were known as dumb terminals because they had no intelligence. They could only do what the mainframe asked them to do. They could do nothing on their own. They were just simply an output device to show you as to the results of your work, and an input device where you could enter things. So this was computing in the early 1980s. You can see that's about 40 years ago. And then if you go on to the next chart, please, which says on top, computing yesterday in 1985, all right? You can see how things are changing over the next 5 years. Mainframes are still called mainframes. They still have the channels. Excuse me. The console is still there. The card punch is still there. The printer is still there. But now the terminals can be much, much farther away. They can be up to 30 miles away. The start of telecommunications as we know it today. And they were no longer at the end of actual physical cables or four-way wiring, etc., etc. They could actually be 30 miles away, and the start of telecommunications came in the 1980s. By the way, incidentally, please, all the people who attend the talk, please ask me any questions you like as I go along. So you don't have to save your question till the end. You can ask me as I'm going along. We can also have questions at the end, of course. But if you have any questions as we're going along, please don't hesitate to ask me. And the whole computing system, as I mentioned earlier, took a whole room. Now, going on further, next chart, please. It says 1990. The whole system that I had in the last chart and now in that big rectangular box which says whole computer system. In addition to that, within an organization, there'd be departmental systems. So for instance, IIT Kharagpur, maybe Professor Pal would have his own little computer system, departmental systems. And of course, IIT Kharagpur would have one main in their computer center. And of course, there'd be terminals as before, but these were long distance now. They could be around the country, around the world, actually, long distance telecommunications. So telecommunications came into its own in the early 1990s. And the terminals were still at users' desks. There were still primarily dumb terminals, but there was some intelligence that's beginning to come into the terminals. They begin to become small computers in their own right. The departmental systems were much like the whole computer system. They had drums and disks and printers and so on, etc. Mainframe was still the king. The departmental systems, of course, had intelligence, so it was not just the mainframe, but before this, the mainframe was the king. Today, you don't even use the word mainframe. If we go on now to the next chart, 1995. Now the terminology has changed from computers to servers. Servers, now you don't call them mainframes anymore. The word server started coming into being. And you had the coupling of mainframes, more powerful computer systems. There were multiprocessors and coupled systems, etc. The departmental systems were now all hooked up to the mainframe via telecommunications. And the telecom could be hundreds of miles away. And you got the beginning of laptops coming as terminals. Laptops, of course, are small computers in their own right, so they had a lot of intelligence in them. So they are becoming terminals. People were using small laptops as terminals. So this was the computing in the mid-90s. Next chart, please. on the top it says computing yesterday 2000. Within that big rectangular box is all the picture you saw in the previous chart. And then you also had hundreds of miles away across the whole globe now. You had these terminals of the laptops, etc. There's the beginning of terminals and the use of laptops as terminals. So this is computing as of about 20, 25 years ago. Next chart. Then we had a lot of things changing along the way in the IT industry. You had beginnings of things called outsourcing from client premises. Clients were the people, were the customers. Client is just another word for customer. To in-house service provider premises. Client were customer. For instance, IIT Kharagpur would be a client. And you had beginnings of organizations who just gave the IT services, and they became known as service providers. So you had service providers, like you have the companies in India, they'd provide computing services to clients. And many clients would outsource this, so they didn't have it on their premises anymore. They had physically, the computers were not on the customer's premises. They went to the service provider. So IBM was a service provider. Wipro was a service provider. So those are the service providers. Service then started coming from remote sites. There were no data center on premises. Some companies didn't have a data center. They saw no need to have their own building, no need to spend money on having their own building, their own staff, etc. They would contract or outsource everything to a service provider. And the service provider would have the computer center and the staff, etc. The service providers in turn started looking for economies of scale. So if they had 5 customers in a certain location, say in Kolkata, then rather than having 5 computer centers, they started looking for economies by having them all co-located in one data center. So that was the beginning of data centers, or the use of the term data center. The data centers, since they were serving multiple customers, multiple companies, had to be hardened, in other words, against power and security backups and so on. So hardened sites became the thing. Then optical fiber came along. This was in the late 2000s. Optical fiber came along, huge increase in capacity and large decrease in cost of telecommunications. That's when the big telecommunications revolution came with the coming of optical fiber. So like terminals, it makes possible connecting of computers around the world. So now not just terminals, but computers were being connected to each other. And this gave rise to the notion of cloud computing, which I'll illustrate in just a minute. So these are some of the improvements that came along, or concepts that came along, as the computing hardware and software changed. So if you looked at an organization at that time, say in the early 2000s, it has its IT services. The IT services now is partly in-house, partly outsourced to a service provider, and partly cloud-based. Cloud-based means it's somewhere up in the clouds. Nobody knows where it is, etc. You know, today, for instance, a user like you or me, when we do something on a computer, we enter something and we hit the enter button. We have no idea where in the world it's going. It could be going to South America. It could be going to a data center in India. It could be going to a data center in Japan, in Australia, US, Europe, whatever. The user has no idea where his computing is actually coming from. That's the notion of cloud. Growth of cloud computing to users. Then you come along further, another few years, and computing today, an organization like let's say IIT Kharagpur. It has its IT, it has application services, partly in-house. IIT Kharagpur, I understand, I was just talking to Professor Pal earlier, you still have a data center, so it's partly in-house, and partly it's done up in the cloud. And clouds have now become of 2 kinds. The in-house, by the way, partly, as I mentioned earlier, can be provided by the client itself or the customer itself, or by a service provider. I don't know if IIT Kharagpur contracts with Wipro or companies like that for its service, or IBM or whoever. And similarly, the cloud can be now either public or private. Private cloud is a cloud that's for any one organization. Public cloud is a cloud that's shared by many, many organizations. And the economies there, and of course, all because of costs. When you have sharing, the costs go down, therefore the growth of cloud computing. And so now it's a hybrid IT infrastructure. An organization has its own in-house, plus its part service provider, plus its private cloud, or its public cloud. Any questions so far? Okay, then I'll carry on. Now that was the hardware side of things and how things have changed with both the computing hardware, IT hardware, as well as telecommunications. Of course, you know, IT, all the equipment does nothing unless you have software. All the equipment just sits around, will do nothing at all. It's totally incapable of doing anything unless there's software to drive the hardware. So let me give you the software, corresponding software picture. First of all, you had just the computer. The next slide. It says hardware yesterday, 1970. You just had the computer, but the computer on its own is of not much use. It cannot do anything at all. You have to have software. So sitting on top of the computer was a thing called the operating system that would drive the computer, that would make it work, that would move data from the storage into mainframe, into the CPU, from CPU back to storage, that would do the computation, that would provide the results, etc., etc. The operating system had things known as compilers. People in those days wrote programs in languages like Fortran or COBOL or whatever. They had to be changed into machine language because a computer is a piece of hardware. It only recognizes zeros and ones, the absence or the presence of current in the circuit. So something had to change from the language that people wrote computers into these zeros and ones, and those were known as compilers. They compiled the program in machine language. Device drivers are, as I had mentioned, some devices, punch card readers, printers, etc. There had to be software to drive those devices. If you wanted something printed, something had to tell the printer how many lines per page, how many characters per inch, etc., etc., what kind of font to use, and all. So those were all in the device drivers. So the device drivers that drove printers and card punches and card readers and application screens and so on. And the end user applications sat on top of these. So the end user now didn't have to bother with writing the compiler or the device driver. That was all provided to him as a part of the computing system. On further, a few years later, I'm the next chart now. It says software yesterday, 1985. On top of the compilers and device drivers and operating system, you now had things called database systems, telecommunications. Telecommunications, we have seen how important that was. You couldn't connect anything to anything without telecommunications. And it wasn't just enough to connect it physically with wires. You had to have software to drive them. So those are telecom systems. You had, and then your database systems. Everything is done with data. Nothing is done without data. So you had IMS and CICS and so on. So you might have heard of some of these database systems. And now, of course, there are many, many more database systems. So your database system, all this meant that the end user writing applications didn't have to worry about any of those things. They were all provided for him as a part of the computing, environment. Next chart. Then on top of that, you had companies writing applications, enterprise applications. Enterprise is just a large organization. Enterprise applications. Next chart. On top of the enterprise, you had application enablers. Now slowly it became possible to go more and more into the applications, into doing, for instance, Industry 4.4, where Industry 4.4 requires a lot of software, requires a lot of programs, etc., etc. And then the end user applications sat on top of that. Today, the stack is even more. Today, on top of that, you have LAN, which is local area network, WAN, which is wide area network. Those, you have to have software that enables all of those connections, all of those telecom communications. So telecom has come a long ways. It requires a lot of software also. You have gateways into these so that you could protect, you could have firewalls so that from a security perspective, from etc. So you have things called firewalls and gateways and the end user application sits on top of that. Finally, today you have platforms. You hear of platforms. So sitting on top of this stack of software, you have cloud tools, security, encryption, etc. End user application, and then you have the platform. Today, people use platforms. So supporting that platform, you have this whole stack of software that's there that people have written that are now available to the users of computers. That's why using computers become so much easier, and that's why, because it's easier, therefore it's being so much more widely. Today everybody uses computers for everything because they have all the software supporting them, behind them, etc., etc. You saw the picture of computing yesterday. This is the picture of computing in 2005. Now I've introduced the LANs and the WANs, so let me just explain this chart. Starting at the top right-hand corner, you have an organization campus like let's say IIT Kharagpur. People have desktops and laptops. They are now connected into a local area network, LAN. That LAN has servers. What are servers? They're computers. They run programs. They give you answers to your questions, your computing needs. That LAN itself, by itself, is connected via a gateway, which provides firewall and security into the WAN, a wide area network, which could be worldwide. And that on that wide area network, there could be other mainframes, many mainframes. And the wide area network could be connected via gateways to another WAN, servers with servers mainframes. So you can see now this, you sitting at your desktop or your laptop are literally connected to computers around the world. That's why when you do something at your desktop, you don't know where in the hell this actually is being done. Today, that picture has modified a little bit more in the sense that the laptops and iPhones can all be wireless. So you are sitting at your laptop, or you're sitting just even with your iPhone now. Many applications can be done with just iPhone. And through this computing network today, you're connected to computers around the world. And on the computers, there could be Amazon, there could be Google, there could be all the other platforms, etc. And this is cloud computing. That's why it's called the cloud is a computer. The worldwide network is the WW Cloud, worldwide cloud, and you have servers there of all kinds, etc. Google's, Amazon's, and you sitting in your laptop or just with your iPhone, you are literally connected, both physically as well as software-wise, as well as hardware-wise, to computers around the world, and you can do so many things without all the intricacies of software because you have that software stack supporting you in all these computers. So this is computing today. That was going to be my presentation. Now let me open up to questions. I'm probably 10 minutes short, but I'll be happy to answer questions. Has this been of any interest at all?
Yeah. Very good. Yeah, it has given us the understanding about the evolution of the computing systems and all. So some the generic the questions is coming up in my mind. I do not know whether any question is there in the chat box. So let the audience write, but before that, let me interact with you. How do you see the growth of the cloud computing or the cloud services? How much it would be effective for the MSME sector, because I work the Center of Excellence in Advanced Manufacturing Technology at IIT Kharagpur is working for the industry's problem, and we are trying to solve the problems for the MSME sector. And MSME sector in India is very in a very the bad shape, I would they mention, and they desperately they are looking for the industry 4.0 solutions. So the solution has to be the low cost, and thinking all aspects of the MSME sector in India. How do you suggest that whether these cloud services or the cloud computing, how much
Could you
effective?
explain the acronym MSME?
MSME is the micro, small, and medium, the enterprises. It's a
Right,
SMEs. You call it as a SMEs, small and
right,
medium
right.
enterprises.
Okay, all right, okay.
Micro, small, and
You
medium
see,
enterprises.
yes, okay. You see, the whole thing is driven, most advancements in most fields is driven by the need for lower cost. And as you have seen over the last 50 years, everything that has happened, all the evolution that has happened, has always led to lower costs. Otherwise, it would not be taken up by anybody. So you see, this whole notion of sharing is to lower the cost. That's why instead of a company, whether it be small or large, an SME or large company, have their own data center, they will share it with others to lower the cost to themselves. So if you have a data center that costs 100,000 rupees, if you can share it between 5 companies, the cost to each company is 20,000. If that were to be done just by that one company, it would be so much more. So cost driver has been a motivation and is a motivation throughout, because unless you can reduce the cost from what it was before, nobody will adopt it. So, so hence for SMEs, cloud computing has a lot to offer because it can offer you the ability to lower your cost because you're sharing more and more. You don't have to have your dedicated equipment, people, hardware, software, IT staff, etc., etc. The downside to that, of course, is the more you share, the more is the risk from a security perspective.
Yeah.
And you've probably seen lots of articles these days where data has been hacked into, data has been, private data has been lost, etc., etc. So you see, the more you share, the more is the exposure to security. So that's the other side. And for some SMEs, security might be very, very important because they may be working on something which nobody else is working on, and that is their unique, their proprietary thing, and they don't want it to be lost or etc. So that's the downside of sharing.
Mhm.
So each SME therefore will make its own decision where to draw the line between, on the one hand, trying to drive costs down, on the other hand, trying to secure its data, its information, etc., etc. And you'll get different solutions. But now, all the advancement that has happened gives companies a lot of options. Does that answer your question?
Yeah. So the cost is one factor, no doubt, for the MSMEs, and that's a major concern. Everybody
Yes.
appreciates that. But having said the cost is the critical factor, the need. I'm just wondering that do they need this service for their activities to make their the activities industry 4.0 compliance? Because some of the time when I give the present the webinars and all at different forums like the BCCA, Bengal Chamber of Commerce, in other places CII and FICI and others, and then this question the come up. So what is your view, like how do you think that what is I mean, do they really need it?
That's a good question. The thing is, the need is driven by something. So if there is a need, for instance, for saving costs, then the need is there.
Yeah.
If they are floating with lots of money and they don't need to save any money, etc., then the need is not there. So you see, cost is one factor. Security, I mentioned, is another factor.
Yeah.
They may have the need from a cost perspective, but they may not be able to or be willing to take the risk of their proprietary information being made publicly available because they're sharing all the computer systems, etc., etc. So that might negate that particular need. You see, so the need is driven by by certain things. It's not just something that happens in isolation. So therefore, the need will vary. If somebody is in an old industry where there's not much proprietary information, where things are just being done the same way that they have been done, there's not much data to be protected, there's not much intellectual property to be protected, then the need for sharing, then the risk is lower, and maybe they will share. On the other hand, a company that's just starting up that wants to protect its intellectual property, maybe they don't want to take that risk. So the need is not there, you see, or the need is overcome by other needs. The need for security, that's also a need, you see, okay. So does this answer your question a bit more?
Yeah. So,
All right.
sir, the two questions have come up. So let me quickly read those questions.
All right.
You can give the answers, and then after that, I'll come back again for some other, the input regarding the industry academia collaboration.
All right.
The question is that from Sujit Day, that how does cloud computing efficient in dealing with high performance computing, wherein millions of computational iterations are carried out simultaneously? How does it computationally time efficient for
Yes.
large iterative process? And all?
Yes. The answer is along the lines I gave you about cost. In other words, if it was not efficient, if it did not perform properly, people would not use it. That's the best test, you see, okay? I mean, it's like if IIT Kharagpur suddenly brings in a new computer in their computer center. If that computer is not performing well, people won't use it.
Yeah.
It's the same thing with cloud. Yeah. If people try the cloud and find that the performance is not acceptable, they will stop using it. So for something to be successful, it requires it to be both efficient and less costly and all of those things, you see, okay? So now obviously the performance of doing something on your own campus is probably going to be better than having it done halfway around the world in South America, So I mean, there's some degree of I won't say inefficiency, but there's some degree of slowness built into cloud computing, because now data has to travel thousands of miles instead of, or maybe 5 miles, and data takes time to travel, etc. So there's some impact on performance, no question at all about it. There is some impact, but that impact has to be tolerable, has to be acceptable to the user, otherwise they'll not use it. So I will not say that cloud computing is as fast as doing it in your own computer on your own campus, but certainly it provides so many other benefits that cloud has become very, very ubiquitous now. Its main benefit is that you get so many platforms out there that you have to do very, very little yourself. You can use the platforms. Google and Amazon, if you have a question, okay, you can ask Amazon, you'll get the answer in seconds. Now, if you had to write your own programs to find out all those answers, it would take you years and years and years. So you see, in that example, the performance of the cloud is much better than performance of your own computer. In some other examples, it could be the other way around. If you're doing a major engineering calculation for your own design of turbine blades or whatever, etc., it may be much faster doing it on your own dedicated computer system than doing it up in the cloud somewhere. Does that answer the question? I'm sorry.
Yeah.
These questions don't have very clear-cut answers all the time.
Exactly. Just to I'm sharing my experience. Like, we talk about the cloud, the servers and all the data has to be kept in the central, the location so that it can be accessible and all. But at the same time, the latency matters a lot, specifically for the real-time process control. Because if you cannot get back the feedback, the real time, and uploading the data from the system to the cloud for processing, and then from the cloud. So we also, sometimes we observe that until and unless the communication is very fast, like the 5G or maybe the 6G or something else,
Yes.
The some of the applications in the manufacturing process we can't apply, we can't use the cloud servers as one of the key elements.
Yes.
It is being used for the static data, not for the dynamic data. That's sort of we have
Exactly. Yes, you're absolutely right, and I think you've explained it very, very well. Latency is a problem, of course. The farther you go, the more is the impact of latency. Now, in many applications, latency is not that critical. In many other applications, latency is absolutely critical.
Exactly.
Again, it depends on the application. You see, and and of course, as I mentioned, the other aspect, of course, is security. If you're sharing your own proprietary data up on the cloud somewhere, that's available to everybody else.
Yeah.
So you see, there's that aspect also. It's like everything in life, everything has pluses and minuses.
Yeah. So in this particular line, one more question has come up.
Sure.
The question itself also gives a little bit of answer. Can you optimize the sequence of these computations to reduce the time latency?
Okay. Now, you see, if you take a look at my chart that's up there, all right? Now look, on that one chart, you can see the cloud can be so many different computers owned by all different companies. Google and Amazon, I've just shown two examples there. There could be hundreds of computers up there. Now, for anybody to optimize that, I don't think we currently have organizational structures that match that. You see, okay? So you see, I mean, to optimize something, you have to have a structure that has responsibility for the whole thing. There's nobody today that's responsible for the whole cloud. That's why it's called cloud computing. You see, okay? Because there's no one organization that's running the cloud. There are private clouds, of course, and those you can optimize. There are some companies, worldwide companies, like let's say IBM. IBM may have its own private cloud where the IBMs around the world can access. Those kinds of clouds you can optimize because one company is controlling it. But true worldwide clouds, there's no one organization that has responsibility over the whole thing, and therefore it's difficult to optimize.
Sir, the one question is, I do not know whether it has got any specific answer. Like because we are not in the field of computing, I'm talking about my own the experience or the background.
Yes.
So we heard the term called the fog computing, cloud computing. So generally the question comes up in my mind: what is next? So what is your view?
That's a very good question, a very difficult one to answer because that's like trying to look into the future. I mean, if you went back 20 years ago, nobody could have foreseen the cloud as it is today.
Yeah.
So I'm going to take the easy way out and say, look, I don't know. I mean, and I mean, I wish I knew. People who know the answers, they are there making, doing good things and making tons of money, etc., etc.
Yeah.
All I can tell you is that I think it will go on evolving. I mean, there's things that are going to stand still. Nothing stands still. After all, there are hundreds and thousands of people working on various cloud applications. So there'll be incremental improvements in all of these things. I showed you the whole software stack.
Yeah.
That every single item in there is being improved. I showed you a hardware stack. So there'll be gone improvements, but I cannot foresee or some huge change like from cloud today to something else entirely. I think it'll be evolutionary. All developments are typically evolutionary, and I'm sure it'll go on evolving. Things are not going to stand still where they are today.
Good. So
that's the best answer I can give.
Yeah, I know that it's very difficult to answer because there is no specific answer, in fact.
No, that's right. And just from this small presentation, you saw how many components there are.
Exactly.
The hardware components, software components, telecommunication components. There are literally hundreds of components that form computing today, as I've shown in this chart. Hundreds, and there'll be developments in every single one of those.
Yeah.
They will all evolve.
Actually, I was not thinking, I was not thinking about the incremental changes in the components and the products and all. What I was thinking is that, if you consider cloud computing is a concept, if fog computing is a concept, then
Yes.
I mean, what is next? Like, how do you see that the computational world
Yes. Yes.
mechanisms?
Yes. I understood your question. I know you were not talking about incremental.
Yeah.
I was talking about incremental because I cannot foresee the big change that might be there. So what I was saying is that I think the big change will come by incremental changes in all of these things.
Yeah.
I don't think it'll come in one big bang,
Yeah. So, sir, one more question has come up. Does environmental situation like high temperature, humidity affects the communication latency? So cloud communication would be affected to take census data inside a furnace.
Absolutely. I mean, all the factors that affect latency and and climate is a major factor.
Yeah.
That's going to affect it. It's going to make things more complicated. It's going to and maybe it'll slow down some of the incremental changes. Maybe some of the incremental changes will be to address these new problems coming up, like with the climate and so on, etc. You're absolutely correct.
Yeah. Sir, you have worked 30 years in IBM, and then you moved, to Warwick Manufacturing Group or at the University of Warwick in the teaching profession. And I know that you were one of the pioneers in coming up with designing the industry focused, the courses at Warwick Manufacturing Group. You worked with Lord Kumar Bhattacharya, who was the founder of Warwick Manufacturing Group in the University of UK. So I'm just, would like to have your guidance, because Center of Excellence in Advanced Manufacturing Technology at IIT Kharagpur, we are working for the industry, solving the industrial problems on various fields in the field of manufacturing. But at the same time, we are also floating courses. And I would like to take your advice that what are the key factors when you design a course specifically for the industry professionals?
Yeah, when we were doing that at WMG, there were a couple of things that actually we had to keep in mind. One is, it's like anything else. You see, if you come up with dog food that the dogs don't want to eat, then that's a total waste. So one test is industry interested in what you are proposing or suggesting? Okay. We found that to be very, very key. And secondly, we found that interest is evidenced by whether they are willing to participate in the actual teaching, in the actual dissemination of that information. If they want to be active, then it means they're enthusiastic about it, they think it's a good thing, etc. On the other hand, if they have an attitude that take it or leave it, then it's not going to be very, very successful. So those are some of the signs that we would be looking for. We would talk to industry, we'd find out what ails them, what is it that's holding them back, what is it that they think they need to do more, which area do they need to do more, and then we'd try and design things to address those needs with their participation, so there would be a joint thing. We would not try and do something that was only excuse me, that'd be only academic specific. We would truly make it a joint industry academia combination. I know these are general answers, but one can only give general answers to in a forum like this, because we have to get down to specifics. We have to look at what areas are your strength areas.
So when you were designing the courses, the industry professional, Ananta, would you please mute the microphone of Professor Mishra? Yeah. So when you are designing the courses of for the industry professional, you know what I was thinking is that your expertise or the experience while working in IVM for so long, did that help?
That helped greatly, actually, because you see, we knew what IBM was struggling with,
Yeah.
and therefore we knew that in this whole IT sector, what were some of the major challenges, and therefore all the companies in this sector would have those challenges to a certain extent or another. Okay. So that was very helpful in that sense. You see, okay, and that's where the partnership is important, because if you're only an academic institution, like say WMG or on its own, University of Warwick, then you don't have that industry perspective.
Yeah. Yeah.
You see, you need that industrial partner with you.
Yeah.
To do the thinking with you.
Yeah.
As to what are the challenges that industry is facing, so that you can jointly then come up with academic solutions.
Yeah.
To help industry.
Yeah.
And that leads to the best results, I think.
Yeah, that's really important. And another thing is that when designing the courses, like when delivering the lectures and all, did you consider the industry professionals as the experts for the lectures, or it was purely by the academicians of WMG or the University of Warwick?
No, as I mentioned earlier, we wanted industry participation.
Yeah.
In the form of case studies or whatever, or their experience or whatever. You see, okay. We wanted that input because that makes it more believable to other industries.
Exactly. Yeah.
If it's just only an academic institution offering something, then it's like any other course.
Yeah.
Whereas if there's industry participation in that, even in the form of just some guest lectures, and some case studies, etc., that makes it much more believable. And we used to find that the students attending would be much more interested in these case studies. They'd have a lot more questions, they'd all kinds of things, because somehow they felt that was more real, if you will. You see, okay. So I think some degree of participation by the industry is important.
Mm-hmm. Yeah, we are also trying that for our different the courses and the training programs and all. But let's see, because the industry academia cohesive bonding is not so strong as compared to the WMG and
Yeah,
other.
yeah. I can tell you, I mean, our experience was that most of the time industry was very willing to participate. I mean, they saw this as a bit of an honor to be asked to take part in these things. So if you can position it that way, then you'll have better luck with industry. See, okay.
Okay, I think so. Sir, we're closing. I mean, we are almost at the end, and so yeah. So how could cloud quantum services are effective than traditional cloud servers? Some of the courses and all, some of the questions and all. So those questions can be asked, then later on. So let us not.
Yeah, if there's any questions that you want to send me, just send them to me. I'll answer them. If there are any other questions anybody has, you're most welcome to ask me any question. I may not have the answers as you have seen, but I'll answer you to the best of my ability.
So thank you so much for your presence, and we are so glad that you have taken out time and then agreed to our invitation to give a lecture in this platform. And we look forward to see you physically at our Center of Excellence and take your guidance to take the center ahead.
Thank you, Professor Paul, for asking me, for inviting me, and for being so patient and monitoring the whole thing and asking questions and so on. I hope the presentation has been of some use and of some interest.
Yeah. As I mentioned, as I mentioned at the beginning, that the manufacturing is very much interdisciplinary, and that IT and
Yes.
concept of the IT and the communications and the cloud.
Yes. Yes. Yes.
Yeah. So
Yes.
in manufacturing engineers or the professionals, they also
Yes.
they take
That's
use of this facility, and they need to.
exactly. Yeah. Yes. Exactly. Thank you very much. Yeah.
I now request Ananta to let us know the speakers for the next 2 weeks, because we have completed today the 50th week and 2 more to go. It's a 1 year long. Yeah, thank you, sir, once again. Yeah. And the next week, that is the 51st week webinar, would be the set by Professor Jian Kao. Professor Jian Kao is a faculty member in the Northwestern University, and she is also the editor-in-chief, Journal of Material Processing Technology. So she'll be talking about the advanced manufacturing and its industrial application. And Ananta, the last week will be our closing the session, the 52, the webinar. This should be delivered by Professor Suman Chakraborty. Professor Suman Chakraborty doesn't need any introduction at all. Professor Chakraborty will be talking about the affordable healthcare equipment manufacturing. And on that particular day, that is the last, the week, that is 12th of March, we are also planning to invite some of the industry professionals to take their the views, guidance, so that the Center of Excellence in Advanced Manufacturing Technology, grow up in coming days. With this, I'd like to close today's session. Thank you so much. You all can watch the previous videos by scanning this the code. Videos are also available in the YouTube. You can type the Saturday Manufacturing Talks. All the 50 webinars are there. And at the end of after completing this mega webinar series on March 12, we'll also be coming up with a compendium. In that compendium, the abstracts of all the webinars would be there, and along with the photograph and the details of the speakers and all, and the address details. So if anybody is interested, the soft copy would be circulated amongst you all attendees. And if you're interested, you can contact them, take the research forward. And that was the purpose of this the mega webinar series, to create awareness amongst the people in the field of manufacturing. Thank you so much. Have a nice day.